Hey there, welcome back. In this video, we're going to go over where the inverse derivative trig functions come from. And for some of you, this might even be a better way than memorizing the inverse trig functions and applying them, right? So that'll be up to you determining that. Either way, this is rad, and it's why the inverse trig functions work the way they do. Let's go. Y equals arc sine of u over a. We want the derivative of that. Now, we just can't roll into town and be like, let's just take the derivative. We don't know what the derivative of that is. So the best way to do this is to rewrite this by saying if arc sine of u over a equals y, since it's an inverse function, we can switch the input and the output and do sine of y equals u over a, right? If arc sine of u over a is y, then sine of y equals u over a. And remember, we get angles out of inverse trig functions. So the output of inverse trig functions are the angles and the input are the ratios. The way that we understand trig functions normally would be the sine of the angle equals out the ratio. So let's deal with that. Now what we do is we take the derivative of both sides with respect to x. U, by the way, is a function of x. So I'll take the derivative of both sides with respect to x. D by dx, oh, we'll squeeze in a d by dx over there, why not? A is a constant, u again is a function of x. So the derivative of cosine with respect to x, cosine of y, don't forget, chain rule, times dy dx, that's implicit. And that is equal to, well, the derivative of u is just u prime. A is just chilling. It's like you're doing 1 over a times u. That's a coefficient. So it's going to be u prime over a. All right, now, from here, we're going to solve for the derivative. Dy dx is equal to u prime over a. We'll divide both sides by cosine, right? So dividing by cosine is the same as multiplying by 1 over cosine. And so neatening that up, that's u prime over a cosine y. And you might be like, wait, what the heck is this? Well, in fact, it's not an answer yet. And you know what? I'm going to keep it as 1 over cosine y. Why not? So the question becomes, what does that equal? To find the answer to what is this equal to in terms of u and a, because those are the inputs that we have, we got to write out a triangle. So we'll write out our triangle here. I went over an activity with this earlier in my earlier videos reviewing how to draw a triangle for that, so I'm just going to jump right into it. You have the sine of y equals u over a. That's what we had before, right? Remember, this is sine of y equals u over a. So the angle y could go here or here, it doesn't matter. I like to put it down there on the ground floor. U is the opposite of y. A is the hypotenuse, because that's the definition of the sine ratio in a triangle. To find this value here, we're going to use the Pythagorean theorem. So we've got u squared plus, I'll call that the adjacent squared, or adjacent squared, equals a squared. And we'll solve for adjacent squared, so the adjacent side to y. Adjacent squared is equal to a squared minus u squared. And so now from here we take the square root of both sides, so we get the adjacent equals the square root of a squared minus u squared. Okay, now we're getting somewhere. So that's the square root of a squared minus a u squared. Now, from here, we need 1 over cosine. That'll give us our answer. Well, what's 1 over cosine? Well, you got u prime over a. Cosine y is typically, always, adjacent over hypotenuse. So this is going to be the square root of a squared minus u squared all over a squared. 1 over that flips that fraction. So you get u prime over a times a all over, the square root of a squared minus u squared. The a's divide out, and you're left with the formula which you see in the earlier lesson videos. Dude, that is rad. So that is your derivative function. So how could we use this process start to finish? That's what I want to go over. You can use your formula, right? No problem. But how can we use this process start to finish to solve it out? Well, what I can do is I can form up my triangle. Might as well do that from the start. And so this is going to be 3x, that would be the opposite of y, all over the hypotenuse is 4. And I'm going to skip a little bit here and say, well, this will be the square root of the hypotenuse squared, 16, minus 3x squared, 9x squared. Again, that's using the Pythagorean theorem and this logic right here. Now, from here, what we can do is we can say, well, the sine of y is therefore equal to 3x over 4. And just take the derivative of both sides if you don't want to memorize that. So the derivative of the left side is cosine of y times, we'll call it y prime. The right side is 3/4. That's the derivative. And then we solve for y prime. So y prime is equal to 3/4 times 1 over cosine y. And what's 1 over cosine y? Well, that's the reciprocal of cosine, or secant. So normally cosine is root 16 minus 9x squared over 4. It's going to be the flip of that since it's 1 over it. So we'll do 4 over root 16 minus 9x squared, right? We're doing the adjacent over the hypotenuse, but flipped. The 4's cancel, and you're left with 3 over root 16 minus 9x squared. So this is for those of you that don't want to memorize a formula. I'm not a fan of doing it this way necessarily. I actually like the formula in this case. If you look at this, u is equal to 3x, a is equal to 4, so you'd have the derivative is 3, right? That's u, so that's 3. A squared is what goes in the denominator, that's 4 squared is 16. And then we've got u squared, 3x squared is 9x squared. So using the formula is much quicker. All right, I'm going to show you then where arctan comes from using a similar scenario. So again, we've got tangent of y would equal to u over a. And when we look at this as a triangle, that looks like this. We know we're going to need the triangle now. You got a y down here. You've got u is the opposite of y over the adjacent because it's the tangent ratio. And when we do the Pythagorean theorem, this would be, well, let's call that the hypotenuse squared equals a squared plus u squared. And so h would be equal to the square root of a squared plus u squared, h being the hypotenuse. So that is the square root, just Pythagorean theorem, of a squared plus u squared. Now from here, what we need to do is take the derivative of both sides. So I'll just say d by dx. The derivative of tangent is secant squared y times dy dx. Chain rule there with the y, we're taking the derivative with respect to x. As we saw in the previous part of this video, the derivative of u is just u prime and a is just a constant along for the ride. Now what I'm going to do is I'll divide both sides by secant squared. So dy dx is equal to u prime over a times what's basically 1 over secant squared y. Right? Division is the same as multiplying by 1 over the thing. This simplifies to u prime over a times, that's cosine squared. Right? If 1 over cosine is secant and we're doing 1 over cosine, it ends up just being cosine. It's the reciprocal of secant. So now we're going to use our triangle here, and that's going to be equal to u prime all over a times cosine squared is adjacent squared over hypotenuse squared. So that's adjacent over hypotenuse, square root of a squared plus u squared. And we're squaring all that based on what we found here, because that's cosine. That gives you a squared u prime all over a root a squared plus u squared. Ooh, that's pretty nice. Pretty nice indeed. The a's are going to drop down, and you're going to be left with the formula that you saw in a previous video. A u prime, ow! All over the square root of a plus u squared, or a squared plus u squared. As I said before, this is not your typical formula, right? And ooh, I left a square root there. I left the square root there, and that is incorrect. Let me just reduce that down. When you square a square root, ladies and gentlemen, the square root obviously goes away, so my bad. So you're looking at that and you're thinking a times, and this would be a squared plus u squared. Again, squaring the square root makes it a squared plus u squared, and that is the formula that you'll see from before. Not terrible, not my favorite way to go about things, but pretty cool. Again, a different looking formula than most textbooks and teachers will teach. Now, we can do this with the triangle method if you like, or you can use the formula. So let's use the triangle method here. In this case, we've got tangent y is equal to t squared over 3. So y I'll arbitrarily put down there. This is the opposite over the adjacent. So we'll get opposite over adjacent. This will be the square root of this squared, t to the 4th, plus that squared, 9. Now from here, all we've got to do is take the derivative of that. So I'll get secant squared y times y prime equals, this will just be 1/3 times 2t, or 2/3 t. And I multiply both sides. Now we saw before when we multiplied both sides by 1 over secant squared, it was the same as cosine squared. We saw that up here, and I explained that before. So that's going to be cosine squared of y. Now from here, we're going to use our triangle. Let's simplify it down. So I've got y prime equals 2/3 t. Pretty sweet. Times, let's see where this goes, cosine squared. Well, that's going to be adjacent over hypotenuse, 3 over root t to the 4th plus 9. All of that squared. Now, when we simplify this down, check it out. You're going to get 2t times 3 squared is 9, all over 3. Square root of anything squared is itself, t to the 4th plus 9. Simplify that a little further, we get 2t times 3. And I'm going to leave it like that, or 3 times 2t. The 3 and the 9 cancel, and you're left with t to the 4th plus 9. Now, why does this make sense? Because the formula said a times u prime. Well, remember, 3 is a, the upper value is u. U prime is 2t, 3 is a, right there, so there's a u prime. The bottom is going to be a squared. I switched them up. So a squared is 3 squared is 9, and u squared is t to the 4th, t squared squared. That's it. Again, I recommend using the formula, but if this video has helped you to understand where the formulas come from, so be it. If you're like, dude, I'll just memorize the formulas, that's fine too. But this stuff's rad. Peace.